Hello everyone, Aaron here, and welcome back to Leetcode. Today we are doing the longest palindrome by concatenating two-letter words problem. You are given an array of strings words. Each element of words consists of two lowercase English letters. Create the longest possible palindrome by selecting some elements from words and concatenating them in any order. Each element can be selected at most once. Return the length of the longest palindrome that you can create. If it is impossible to create any palindrome, return 0. A palindrome is a string that reads the same forwards and backwards, so LCGGCL is LCGGCL. Sounds exactly the same. And with this example here, that's exactly the palindrome we're trying to create. LC with the CL paired with it and the GG stuck in the middle. Oh, that's... I'll come back to that. So here we can see an AB, a TY, a YT, an LC, a CL, and an AB. We can pair the TY with the YT and the LC with the CL to do those. But the AB doesn't pair with the AB because they're not symmetric with one another. They're identical to one another, so it doesn't count. If we had an AB on one end and an AB on the other, it wouldn't be a palindrome. CCLLXX, each of these is themselves a palindrome, but as soon as we try and join any of them together, we break the palindromeness. And this is sort of an interesting point in what I saw up here. These doubled letters can go in the middle, and only the middle. And you can only take one as well, actually, now I think about it. Can we have repeats in this? Oh, we must be able to. AB goes to AB. Damn. Okay, I had a thought, and the the repeats break my thought. But I think the idea is, because we're not expected to build a particular palindrome, all we care about is, does a letter combo, well, either is it its own pair, in which case, there is an edge case here. If I have two of a thing of a doubled letter, I can glue those on the edges, so they pair up. That's interesting. So what I need to do is basically I need to go through and count import collections. Elements is collections.counter words. So this will count everything for me. And then length can be 0. Mid is false. So we can have exactly one doubled element in the middle, which is why I'm creating this mid thing. So GG here we take as a mid element. If there was a second GG, we're better off not taking it as a mid element and just having GGGG. And then putting the LCCL on the outside. Yeah. And then the length is obviously how we're going to count. Return the length. So for doublet count in else.items, tell boot is doublet 1 plus doublet 0. So this is our reversed thing. If tell bood in else, in fact, no. Yeah, if tell bood equals doublet. So if we are one of these doubly things, a GG, an XX, an LL, a CC, or whatever, what we want to do is basically what we want to do. So if I've seen one of these, if mid is already set, what I want to do is let's come back to that. If mid is not set, I want to take all of them one way or another. Length plus equals 2 times count, because each one counts for 2 letters. If length mod 2 is equal to 1, mid equals true. And the thinking here is that if there's an odd number of these doublet thingies, then I must have taken my mid element in some way. So here there's exactly one element, so by taking it, I've made it my mid element. Here there's exactly one CC, so by taking it, I've made it my mid element. Fine, whatever. Here, if there was, so let's say we had 2 more GGs on here. If I take GG, 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 I've taken 2, 4, 6 letters, and one of them was my mid element. Right, so back up here, if the mid is already taken, what I want to do is length plus equals 2 times count if count mod 2 is equal to 0, else count minus 1. So here what we're saying is, if I've already taken a mid element, so let me write down an explicit example rather than trying to get you all to visualize something annoying. Let's say I had GG, 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 FF, FF, FF. If I take GG, 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 that's fine. I've got 6 letters now, but I can't take FF, FF, FF. Because if I glue an FF on the front and an FF on the back, I've still got an FF that I can't put anywhere. I can't shove it in the middle because that would involve breaking this GG. So I can only take 2 of the 3 FFs. And that's true more generally of if I have an odd number, I can't take the odd one out because I cannot balance my palindrome with that. However, if I can balance my palindrome, then if it's an even count, then I can balance my palindrome, so I can take all of them. Yes. Okay, cool. Otherwise, what we want to do, we're looking at something that isn't its own double, so this is our LC, our CL. Other count is else tell bound. And what we want to do is we want to do length plus equals the minimum of other count. Double it. So on the one hand, I can double it because, so I've got LC, I'm looking for CL, both of these are a 1. So I want to take 1. In fact, I want to do 4 times that, don't I? Yeah. So I want to take, this will give me 2, and the other count will give me 2. So that's 1 plus 1 is 2. Sorry, that's 2 plus 2 is 4, basically. If I had, let's go back up here to our example. If I had LC, LC, CL, I have 2 LCs but only 1 CL, so I can only pay off one of them, basically. The other one has to be left out. So that's why we're doing this min of count with other count. So what's the largest number of them I can balance? Ironically, the largest is given by min. And then I want to quadruple that. In fact, no, I do only want to double it, because eventually we're going to see the CL, and that'll count back the other direction with the LC. So wait, how many do I need to count here? Yeah, no, that is still correct. Doubling business. And then finally, if we get something that is this AB, so there's an else case here implicitly, but we'll get rid of it because this is our AB case. There is no BA floating in this list, so we can just never balance it with anything. So let me come back to this case because it's a little bit complicated and I'm just trying to wrap my head around it completely. I see the LC. It has a count of 1. The CL also has a count of 1. So I'm going to count. I can balance 1 of these things. It provides 2 letters, so I add 2 to the count. I get to the CL. I see the LC. They're both 1. So I can balance at most 1 of these. It provides 2 to the count, so I'm up to 4 now. And then the GG case we handled up here. There is no mid element yet, so the GG is going to count for 2 letters. We're done. I think that works. Let's do a typo check. In fact, let's go further than the typo check. Let's actually get something that works. Use the example test cases. Ooh, we've made a mistake. 686. Why did that work? For the first one, CC sets mid to be true. So that's that case there. And then mid is true now. So we see 1 count of LL. So we're going to use 1 minus 1 is 0. So you should add 0 to the length. Hang on. I don't understand that. Print telbood. Oh, in fact, doublet is probably easier. Doublet mid count length. Show me everything. What? False. Wait, hang on. Why is the count of... Show me else. Have I misunderstood how counter works? What? Hang on, why is count 0? Oh. Well, that should be a count anywhere in there. That doesn't quite explain my confusion. Oh, count is 1. What was I? No, I was going mad before. I don't quite know what was happening. Oh, was that it? No, I'm confused. I don't quite know what was going on, but I seem to have fixed it. So obviously that mattered in some way. I mean, count mod 2 is always 0 because it's always an even length element. Let's get rid of some of this print statements. And let's do some of our test cases. So if I've got GG, 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 FF, FF, FF. Good, that's what we expected, because remember we were going to take all 3 of those and 2 more of those. That's 5 pairs for 10 altogether. I think that's it. Let's submit it. Excellent. I don't know if that pop-up's ever going to appear. Maybe not today. So, as solutions go, not too bad. This mid business is a little bit weird, but I think it's about the only way we're able to do it. The other thing we could do is keep track of the not just the doublet, but the talbud, so that when we see the talbud as we're iterating through the elements, then we can just immediately skip it, and then we'd turn this into a 4 times. So that would basically do both halves of the palindrome at the same time. Here, rather than needing to maintain an extra set of things we have seen, we just make sure we only half count on the first side, so that when we do the other side, we whole count. Anyway, that is the problem solved. Not too bad one. Quite a neat little problem, actually. This one is a bit funky because it immediately looks like it should be a sort of dynamic programming problem, because you've got this list of things and you've got to choose whether to take them or not take them, and it's an optimization problem. But it's not dynamic programming at all. It's just a simple count and loop. Complexity of this is this guy's order n, this guy's order n, this is order 1, so that's fine. So it's order n overall. Not too bad. Do let me know, well, if you had a go at this, how you got on. But also any sort of suggestions, comments, all of that good stuff. I do enjoy reading all your comments, and I do read all of your comments. So do remember to comment, like, subscribe, all of that good stuff. And I will see you next time. Bye.